and basically outlining what the company will be doing when it comes to electric vehicles, and that has given shares of Toyota.
Toyota Motor is getting into a new venture to develop electric vehicle technology with partner Mazda Motor.
Elon might have been busy with aiding the government and not paying better attention to his company, as Toyota is geared to upping its game in the auto industry. Toyota has just announced an energy car and several upgrades in their batteries that could possibly leave Tesla tailing. The SpaceX founder will lose it once he hears about these. The battle for supremacy. The automotive industry is undergoing the most significant transformation in its history, driven by the global shift toward electric mobility. Two of the most influential players in this transition, Tesla and Toyota, represent contrasting philosophies, timelines, and strategies. While Tesla, under the charismatic leadership of Elon Musk, has long dominated the electric vehicle or EV narrative, Toyota, a pioneer in hybrid technology, has recently intensified its push into the full electric space. As the industry evolves rapidly, the competition between these two giants is becoming more defined, with Toyota's late but powerful entry raising questions. Is Tesla now being tailed by Toyota in the EV race? Tesla has enjoyed a significant first-mover advantage in the EV market. Since the launch of the Roadster in 2008, and especially the success of the Model S, Model 3 and Model Y, the company has set benchmarks in performance, range and autonomous driving technology. Elon Musk's vision and bold execution, often described as disruptive and audacious, have helped Tesla become the most valuable car company in the world by market capitalization. Musk's strategy combined vertical integration, massive investments in battery technology through gigafactories, and relentless innovation in software, making Tesla synonymous with the future of cars. Tesla's full self-driving FSD software, supercharger network, and over-the-air updates gave it a technological edge few could match for years. In contrast, Toyota initially approached electrification more cautiously. Having pioneered hybrid technology with the Prius in the late 90s, Toyota chose to double down on hybrids and fuel cell vehicles rather than jumping headfirst into battery electric vehicles. This conservative approach drew criticism as Tesla soared in popularity and sales, particularly in Western markets. However, Toyota's strategy wasn't without merit. It focused on cost efficiency, scalability, and global adaptability, particularly in regions where EV infrastructure remained underdeveloped. That said, by the early 2020s, the growing global demand for fully electric vehicles forced Toyota to recalibrate its strategy. Toyota's recent announcements and investments signal a dramatic pivot. The company is developing solid-state batteries with up to 200 kilometers, 746 miles of range and charging times that could rival or exceed Tesla's. It plans to release 10 new EV models by 2026 and aims to produce 3.5 million EVs annually by 2030. Toyota is also investing in massive EV production facilities, including a $14 billion battery plant in North Carolina and a Lexus EV factory in Shanghai, targeting both the mass market and the luxury segment. This raises the question, is Toyota catching up, or is Tesla still in the lead? Tesla's advantage lies in its software, brand image, and scale in EV-specific manufacturing. Elon Musk has turned Tesla into a tech company that builds cars, not just an automaker. Features like real-time data analytics, in-house AI chips, and a rapidly expanding charging infrastructure put Tesla ahead in some core EV-related technologies. Furthermore, Musk's vision extends beyond Earth, with the company's image bolstered by associations with SpaceX and a futuristic Silicon Valley-style narrative. Tesla's gigafactories in the US, China, and Germany give it the flexibility to scale quickly and globally. However, Toyota's manufacturing discipline, global distribution network, and financial stability are powerful assets. Unlike Tesla, Toyota has decades of experience producing millions of vehicles efficiently and profitably. Its deep partnerships with suppliers, regional governments, and tech companies like BYD in China and Panasonic for batteries, position it well to deploy EVs at scale. Toyota is not just betting on battery electric vehicles, but continues to invest in hydrogen fuel cells and hybrid electric options, allowing for a multi-pronged approach to decarbonization. Elon Musk has often dismissed traditional automakers as being too slow or bureaucratic to compete. Yet, he has also acknowledged that legacy manufacturers, particularly Toyota, are waking up. In past interviews and tweets, Musk has praised Toyota's production system and even hinted that it could become a formidable EV competitor if it decided to fully commit, which it now appears to be doing. The competition between the two brands is evolving from one of philosophy to one of execution. While Tesla remains the current leader in the EV industry, Toyota is rapidly gaining ground. Tesla's early dominance, driven by Elon Musk's bold vision and technological innovations, made it the symbol of the electric future. But Toyota's scale, manufacturing expertise, and growing commitment to cutting-edge EV technologies, including solid-state batteries and autonomous driving, position it as a serious challenger. The coming years will determine whether Tesla can maintain its lead or whether Toyota's late surge will mark the beginning of a new chapter in the electric vehicle revolution. One thing is certain, the competition between Tesla and Toyota is no longer theoretical. It's real, it's global, and it's just getting started. A worthy Tesla Model 3 rival. In recent years, the global automotive industry has experienced a significant shift toward electrification, with manufacturers racing to develop electric vehicles that balance performance, affordability, and sustainability. Among the pioneers of hybrid technology, Toyota has long been expected to make a bold entry into the all-electric market. With the launch of the Toyota BZ3 sedan, the company has taken a major step forward. Aimed squarely at the popular Tesla Model 3, the BZ3 is a compelling alternative that combines Toyota's manufacturing reliability with advanced Chinese battery technology and a remarkably accessible price point. The Toyota BZ3, officially launched for the Chinese market, is built on Toyota's ETNGA platform, an architecture specifically designed for electric vehicles. This modular platform allows for a low center of gravity, improved handling, and optimized space utilization, all essential characteristics for a modern EV. A crucial collaboration underpins the BZ3's technological advancement. Toyota partnered with BYD, Build Your Dreams, one of China's leading EV and battery manufacturers. BYD contributes its Blade lithium iron phosphate (LFP) battery to the BZ3, offering a strong blend of safety, durability, and cost efficiency. This battery technology is notable for its resistance to overheating and thermal runaway, addressing one of the common safety concerns with EV batteries. Performance-wise, the BZ3 boasts a maximum range of over 600 kilometers, 373 miles, on a single charge, as measured under the China Light Duty Vehicle Test Cycle (CLTC). While this range is subject to variations under different international test standards, it is a noteworthy figure, especially when compared to the base models of the Tesla Model 3. The BZ3 is offered in multiple variants, with power outputs ranging from 135 kilowatts, 181 horsepower, to 180 kilowatts, 241 horsepower, providing adequate acceleration and smooth urban as well as highway driving experiences. Its drag coefficient of just 0.218, lower than that of most sedans, contributes to improved aerodynamic efficiency and energy conservation, again rivaling Tesla's famously sleek design. One of the most striking features of the BZ3 is its pricing. With a starting price of approximately $28,000 USD, it undercuts the Tesla Model 3 by a considerable margin, particularly in the Chinese market. This competitive pricing is made possible through Toyota's partnership with BYD and the strategic local production of components, allowing the BZ3 to serve as a mass-market EV without the premium pricing that often accompanies long-range electric sedans. This price advantage makes it especially attractive to first-time EV buyers and families looking to transition to electric mobility without compromising on range or quality. In terms of design and technology, the Toyota BZ3 sports a clean and futuristic exterior with a focus on aerodynamic styling and minimalistic lines. The interior is equally forward-looking, offering a large central touchscreen interface, a flat-top steering wheel, and a spacious cabin that benefits from the flat-floor architecture of the EV platform. Toyota has also incorporated advanced driver assistance features, although not quite at the level of Tesla's full self-driving suite. Yet it provides a solid suite of adaptive cruise control, lane keeping assist, and collision mitigation systems. These features are aligned with Toyota's philosophy of offering dependable and user-friendly safety systems across its lineup. While the BZ3 is initially targeted at the Chinese market, there is speculation and hope that Toyota may expand its availability to other regions in the near future, especially given the global appetite for affordable, high-range EVs. As countries around the world push for stricter emissions regulations and incentivize electric mobility, vehicles like the BZ3 have the potential to disrupt the market and provide genuine alternatives to the dominance of Tesla. Toyota's entry into the EV sedan segment signals its intent not just to participate, but to compete at a high level. Using a combination of strategic partnerships, advanced engineering, and competitive pricing, BZ3's blend of range, design, safety, and price positions it well in the fast-evolving EV landscape. As the automotive world continues its transition away from fossil fuels, vehicles like the BZ3 are poised to play a central role in bringing electric mobility to a broader audience, the better SUV. Automakers are increasingly integrating artificial intelligence and sensor fusion technologies to bring advanced driver assistance and self-driving capabilities to the mainstream. Toyota, long recognized for its conservative yet dependable approach to automotive innovation, is now positioning itself as a serious contender in this domain. In 2025, Toyota plans to introduce the Bji 3X SUV in China, a vehicle designed not only as an electric SUV, but also as a platform for showcasing the company's most advanced autonomous driving technologies to date. The Bji 3X represents a critical evolution in Toyota's strategic expansion into intelligent vehicles. Unlike previous models that focused primarily on electrification or hybrid powertrains, this upcoming SUV is centered on autonomy and connected mobility. What sets the Bji 3X apart is its development through a high-level collaboration between Toyota, Guangzhou Automobile Group, GAC, and Huawei, three major players in their respective industries. This partnership merges Toyota's automotive engineering pedigree, GAC's local market expertise, and Huawei's cutting-edge technology, particularly in the fields of artificial intelligence, connectivity, and autonomous systems. At the heart of the Bji 3X's innovation is its suite of advanced driver assistance systems, ADAS, engineered to rival Tesla's full self-driving or FSD features. This includes Level 2+ or potentially even Level 3 autonomy, where the vehicle can handle most driving tasks in specific conditions, particularly on highways and in controlled urban environments. The SUV is expected to include adaptive cruise control, automated lane changing, traffic jam assist, and hands-free highway driving under certain conditions. Enhanced perception is enabled through a combination of LiDAR, radar, ultrasonic sensors, and high-definition cameras, all coordinated by a powerful central computing platform. Huawei's role in this collaboration is critical, as it provides the intelligent cockpit systems and sensor fusion algorithms necessary for real-time decision-making. One of the most ambitious goals for the Bji 3X is to deliver these features in a mass-market vehicle, not just a luxury flagship. Tesla has long held a lead in semi-autonomous capabilities through its FSD beta program, but access has remained costly and availability limited. Toyota's approach is notably different. It emphasizes safety, accessibility, and incremental deployment. While Toyota has previously been cautious about overpromising self-driving capabilities, the Bji 3X signals a shift toward greater confidence in autonomous systems. It may not fully match Tesla's most aggressive FSD aspirations immediately, but it focuses on real-world usability and reliability, especially tailored for China's complex and dense urban road environments. The decision to launch the Bji 3X first in China is strategic. China is the world's largest car market and has rapidly adopted electric vehicles and smart car technologies. Moreover, the country's supportive regulatory environment for autonomous driving pilots allows for rapid development and deployment of intelligent mobility solutions. Chinese consumers are also increasingly tech-savvy and open to adopting new vehicle technologies, making it an ideal testing ground for Toyota's advanced systems. Success in China could provide the foundation for eventual expansion to global markets, including North America and Europe. Toyota's investment in autonomous technology through the Bji 3X also reflects a broader industry trend towards software-defined vehicles. Future vehicles will rely less on mechanical superiority and more on digital ecosystems, over-the-air updates, and AI-driven improvements. The Bji 3X is expected to feature cloud connectivity, V2X communication, vehicle-to-everything, and continuous over-the-air updates, allowing the SUV to improve its driving intelligence over time. These capabilities will help Toyota shift from being a traditional automaker to a mobility services provider, aligning with the broader vision of mobility as a service, MaaS. By integrating sophisticated autonomous features, leveraging powerful industry partnerships, and targeting one of the world's most dynamic EV markets, Toyota is positioning itself as a true competitor in the intelligent vehicle space. While comparisons with Tesla's full self-driving capabilities are inevitable, Toyota's emphasis on practical deployment, safety, and partnership-driven development could give it a unique edge. As the Bji 3X enters production in 2025, it will be closely watched as a symbol of Toyota's new direction, one that combines electric power with artificial intelligence to shape the future of driving. Now, let's talk batteries. Next-generation battery technology. As the electric vehicle revolution gains momentum, battery innovation has emerged as the cornerstone of progress. The limitations of current battery technology, particularly in cost, energy density, charging time, and safety, have shaped consumer expectations and the trajectory of industry competition. Toyota, one of the world's most influential automakers, is taking decisive steps to push the boundaries of EV performance by investing heavily in next-generation battery development. With a clear roadmap spanning the next several years, Toyota aims to redefine what is possible in electric mobility. The company's upcoming lithium iron phosphate (LFP) batteries in 2026 and solid-state battery technology targeted for 2027-2028 reflect a bold strategy to compete directly with Tesla and other EV leaders. The first major milestone in Toyota's battery roadmap is set for 2026, with the introduction of a new generation LFP battery. Lithium iron phosphate batteries are already known for their stability, safety, and long life cycles, though they traditionally lag behind lithium-ion batteries in energy density. However, Toyota's upcoming LFP battery iteration addresses many of these limitations. According to company projections, the new battery will be 20% lighter and 20% cheaper than the one currently used in the BZ4X, Toyota's flagship electric SUV. These improvements are not merely incremental, they signal a significant leap toward making electric vehicles more accessible to the average consumer. By reducing battery weight, Toyota can improve vehicle efficiency and driving range. Lower costs, meanwhile, will allow Toyota to offer EVs at more competitive prices without compromising quality or performance. This cost-effective LFP battery also aligns with Toyota's commitment to global electrification, with markets like Southeast Asia, India, and Africa expected to grow rapidly in EV adoption. affordability is critical. Toyota's ability to produce reliable, safe, and relatively inexpensive electric vehicles equipped with these batteries could dramatically accelerate its global EV market share. Furthermore, the reduced use of critical minerals like nickel and cobalt, both of which are costly and often ethically sourced, makes LFP batteries more sustainable and less vulnerable to supply chain disruptions. Looking further ahead, the most groundbreaking development on Toyota's horizon is the deployment of solid-state batteries, a technology that has long been regarded as the holy grail of electric mobility. Solid-state batteries replace the liquid electrolyte found in conventional lithium-ion cells with a solid material, allowing for higher energy density, faster charging, greater safety, and a longer lifespan. Toyota claims that its solid-state battery will offer a driving range of up to 1,200 kilometers, approximately 746 miles, on a single charge, nearly doubling the range of today's typical EVs. In addition to range, Toyota is aiming for ultra-fast charging times, potentially enabling an 80% charge in under 10 minutes. These innovations would represent a paradigm shift, not only for Toyota but for the entire automotive industry. Long charging times and range anxiety remain among the top barriers to EV adoption, particularly for customers in rural areas or those without access to home charging. Solid-state technology addresses these concerns head-on, providing a user experience that more closely mirrors or even exceeds the convenience of gasoline vehicles. Toyota's advancements in this field could position it at the forefront of a new generation of EVs, vehicles that are not only greener but also more practical, convenient, and desirable for the mainstream market. However, Toyota's cautious and methodical approach stands in contrast to some competitors who have made bold promises about solid-state batteries, with little commercial follow-through. Toyota's timeline of 2027 to 2028 may seem conservative, but it reflects the company's emphasis on safety, reliability, and scalability. Solid-state batteries have faced persistent challenges in terms of dendrite formation, manufacturing complexity, and cost. Toyota has reportedly made significant breakthroughs in overcoming these hurdles and is working on manufacturing processes that can scale to mass production, something no other automaker has yet achieved on a meaningful level. Additionally, Toyota's investment in next-gen battery technology is being supported by large-scale infrastructure development. The company is building a massive battery manufacturing plant in North Carolina, slated to begin operations in the coming years, which will produce both LFP and next-generation batteries. With partnerships across the supply chain and a strong focus on research and development, Toyota is positioning itself to not only innovate but also execute at scale, something essential in the fiercely competitive EV market. With lighter, cheaper LFP batteries arriving in 2026 and high-performance solid-state batteries targeted for 2027 to 2028, Toyota is addressing both the short and long-term challenges of EV adoption. These innovations are designed to improve energy density, reduce charging time, enhance vehicle safety, and lower overall costs, all critical factors in transforming the EV landscape. As these technologies come to market, Toyota is poised to challenge industry leaders like Tesla and reshape consumer expectations for what electric vehicles can be. What else can the brand offer in the next few years? Or are they done? The plans for the future, expansion, and production investments as the global automotive industry accelerates toward electrification, manufacturing capacity and supply chain resilience have become just as critical as technological innovation. Recognizing this, Toyota, long regarded as a benchmark in manufacturing efficiency, is now ramping up its investments in electric vehicle production infrastructure around the world. With a strategic roadmap that includes a $14 billion battery plant in North Carolina and a new Lexus EV production facility in Shanghai, Toyota is laying the foundation for long-term dominance in the electric vehicle market. These investments are essential components of Toyota's broader goal to launch 10 new EV models by 2026, and produce 3.5 million electric vehicles annually by 2030. The cornerstone of Toyota's North American electrification strategy is its battery manufacturing facility in North Carolina, a massive $14 billion investment announced as part of its commitment to EV production in the United States. Slated to become operational by 2025, the facility will be one of the largest of its kind in the country. It will initially produce lithium-ion batteries for hybrid and battery electric vehicles, BEVs, with future plans to integrate production of solid-state and other next-generation batteries. This factory is not just a production center. It's a strategic move to localize the EV supply chain, reduce dependence on foreign battery sources, and align with US government policies that incentivize domestic EV manufacturing. The North Carolina plant is expected to support up to 10 battery production lines by 2030, each capable of powering hundreds of thousands of EVs per year. This investment will significantly boost Toyota's capacity to meet North American demand for electric vehicles, particularly as automakers face increasing pressure to comply with stricter emissions regulations. Furthermore, the facility's focus on sustainability, including the use of renewable energy sources and recycling initiatives, reflects Toyota's broader environmental goals under its Beyond Zero strategy, which aims to achieve carbon neutrality across its entire value chain. In parallel with its North American expansion, Toyota is also strengthening its footprint in Asia, particularly in China, the world's largest EV market. In 2023, Toyota announced the development of a dedicated Lexus EV production facility in Shanghai, which is scheduled to begin operations by 2027. Lexus, Toyota's luxury brand, has seen growing demand in China, and the company is positioning itself to directly compete with high-end electric offerings from Tesla, NIO, and BMW. By building a dedicated plant for Lexus EVs in China, Toyota aims to shorten delivery timelines, tailor vehicles to local market preferences, and leverage China's advanced EV ecosystem, which includes battery innovation, software development, and a mature charging infrastructure. The Shanghai facility will also serve as a hub for exporting Lexus EVs to other regions, particularly Southeast Asia and possibly Europe. In doing so, Toyota is signaling its intention to position Lexus not just as a legacy luxury brand, but as a key player in the high-performance electric mobility space. This investment is also symbolic of Toyota's commitment to long-term participation in the Chinese market, despite rising geopolitical tensions and intense competition. Beyond these two flagship facilities, Toyota is investing heavily across its global network to transition existing plants into EV-ready production hubs. Factories in Japan, Thailand, and the Czech Republic are being upgraded to support battery electric production. Toyota's manufacturing system, famous for its lean production and just-in-time logistics, is being adapted to accommodate the different requirements of EV assembly, including the handling of battery packs, electric drivetrains, and software integration. These upgrades are essential to meet the company's ambitious goal of producing 3.5 million EVs annually by 2030, a significant increase from its current EV output. Toyota's production strategy is also deeply integrated with its product pipeline, which includes the launch of 10 new battery electric vehicles by 2026. These models will span a range of segments, from compact urban commuters to large SUVs and performance sedans. Some of these will be branded under Toyota, while others will fall under the Lexus nameplate. The company's EV strategy focuses on offering diversity and scalability, ensuring that electric models are not limited to premium segments, but are available across different price points and markets. In addition to vehicle and battery production, Toyota is investing in the digital and software infrastructure necessary for next-generation EVs. As vehicles become more software-defined, the company is expanding its R&D efforts into areas like connected car platforms, over-the-air updates, autonomous driving, and AI-powered predictive maintenance. These capabilities will be built into the design and production of its new EV models, ensuring that Toyota's electric offerings are not only efficient, but also intelligent and future-ready. With major investments in battery production in North Carolina and high-end EV manufacturing in Shanghai, Toyota is securing its supply chains, aligning with regional policies and preparing for the mass market adoption of electric vehicles. The company's commitment to producing 10 new EV models by 2026 and scaling to 3.5 million EVs annually by 2030 reflects both ambition and confidence. As these facilities come online and new models are introduced, Toyota is poised not just to compete in the EV space, but to lead it. Toyota and Tesla, the road ahead. The global shift to electric vehicles or EVs marks a profound turning point for the automotive industry, and few companies are as central to this transformation as Toyota and Tesla. Though vastly different in origin, scale, and strategy, both automakers are now locked in a high-stakes race to define the future of mobility. As the world moves toward decarbonization and digitalization, the success of these two giants will depend not only on technological innovation, but also on adaptability, global reach, and long-term vision. Tesla, founded in 2003, has long led the EV sector through its disruptive innovations and bold ambitions. Its early bet on battery electric vehicles gave it a powerful head start, allowing it to develop key advantages in software, autonomous driving, energy storage, and charging infrastructure. Under Elon Musk's leadership, Tesla has become more than just a car company. It's a technology platform. The company's vehicles are continuously updated through over-the-air software upgrades, and Tesla's AI-powered full self-driving system remains a defining feature in the autonomous vehicle race. Looking ahead, Tesla is likely to double down on AI, robotics, such as the Tesla Optimus humanoid robot, and its energy products like the Powerwall and Megapack, aiming to create a vertically integrated energy ecosystem. However, Tesla faces increasing pressure from rising global competition, regulatory scrutiny, and consumer demand for more affordable EV options. As more legacy automakers enter the EV space, Tesla's dominance is no longer unchallenged. Supply chain stability, geopolitical risks, and the success of mass-market vehicles like the Cybertruck and next-generation Model 2, rumored to be a $25,000 car, will play key roles in Tesla's ability to maintain its momentum. Its future will also depend on how effectively it can scale manufacturing in new regions such as India and expand beyond the luxury and performance segments where it first found success. Toyota, on the other hand, is a late bloomer in the EV race, but one with unparalleled manufacturing scale and global reach. Having pioneered hybrid technology with the Prius, Toyota initially focused on hybrids and fuel cell vehicles, opting for a cautious approach toward full battery electrics. But that caution is now giving way to a bold transformation. The company has committed to launching 10 new battery electric models by 2026 and aims to produce 3.5 million EVs annually by 2030. Toyota's upcoming innovations include solid-state batteries with up to 1,200 kilometers of range and ultra-fast charging, which could revolutionize EV practicality and address concerns over range anxiety and infrastructure limitations. Toyota's future in the EV sector hinges on its ability to leverage its massive production network, deep supplier relationships, and reputation for durability and reliability. With major investments in EV facilities, like the $14 billion battery plant in North Carolina and the Lexus EV factory in Shanghai, Toyota is building the infrastructure to scale globally. Its partnerships with companies like BYD and Huawei show its strategic alignment with technology leaders in key markets, especially in China. Toyota is also pursuing a diversified approach that includes hydrogen fuel cell technology, autonomous driving, and advanced driver assistance systems, ADAS, which may give it resilience in a rapidly evolving market. The future of both companies reflects a broader trend toward convergence between tech and mobility. Tesla's software-first, innovation-driven model will continue to attract tech-savvy consumers and early adopters, especially if it maintains its lead in AI and automation. Toyota, with its pragmatic approach and global footprint, is likely to dominate in markets where affordability, reliability, and service networks are crucial. Ultimately, Tesla may remain the face of futuristic mobility, but Toyota is positioning itself to be the foundation of mainstream electric transportation across diverse economies. Tesla will likely continue leading the frontier of innovation, pushing boundaries in autonomy and energy integration. Toyota, meanwhile, is poised to bring EVs to the masses with a focus on practicality, affordability, and global scalability. Together, these two titans are not only competing, they are driving the future of mobility itself. As the decade unfolds, their evolving strategies will determine not just their own destinies, but the shape of transportation for generations to come. Are you a Toyota or a Tesla user? Why? Thanks for watching the video.